talking about the smart technology as a tool for diversity, equity, and inclusion in the city of Toronto. Thank you so much for joining us. I want to remind you that you can drop your questions during the presentation in the chat box. The speakers we will be addressing them at the end. And and also, if you want to have a copy of this presentation, you can reach out directly to the speakers. You will see the contacts at the end. So now I'll give the room to our presenters for today, James and Devjuri.
Great, thank you, Catalina. So thank you everyone for joining today. The focus of today's session is based around exploring technology opportunities to support diversity, equity, and inclusion outcomes. We're going to talk through some themes and some concepts related to that subject through the lens of a project that we've been completing with the City of Toronto over the last year or so. So with that in mind, I'll just get straight into it. So my name is James Barker. I work within our Smart Mobility team here in WSP Canada in Toronto. I previously worked for WSP in the UK as part of the ITS team before moving over to Canada and joining the team here last summer. Our team works with government agencies of all different sizes, helping them introduce new technologies into their transportation systems. So projects ranging from the sort of small scale specific deployments of pilot projects like we'll talk about today, all the way through to supporting with the longer range planning elements to support the transition to connected and automated vehicles. I'll hand it over to Devashri just to give a brief introduction to herself as well.
Sure. So hi, everyone. Pleasure to be here today. My name is Devashri Rege. I'm an engineer in training. My background includes transportation engineering, some policy and planning, and finally now smart mobility. So yeah, looking forward to sharing our insights and hearing from you with your questions.
Great, thanks, Devashri. So a little bit of an overview of the session today. I'll give a bit of a background to the project that we've been working on. And then the project's been delivered in two phases primarily. So the first one is a background research phase, which is all about understanding best practice and doing our homework and how to deploy initiatives in this space. So Devashri will walk you through the background research phase shortly. And then we'll move on to the second phase of the project, which is all around designing and deploying a couple of pilot projects to see how technology can support with accessibility around construction hubs. Then we'll finish off with some brief summary and reflections from the project so far before opening it up to questions at the end. So in terms of a little bit of context for this project, so the origins of the project was really in response to the large amount of construction activity that has been happening in Toronto over the last few years. So I did a little bit of research just before this call just to sort of quantify the amount of construction activity within the city. And I actually found out that at one point in the last couple of years, Toronto had more active tower cranes than New York, Boston, LA, Seattle, San Francisco, and Washington, DC combined. So that kind of goes to illustrate the volume of construction that's been occurring in the city in the previous few years, primarily due to economic development, provision of housing, high-rise apartment buildings, as well as huge investments into the city's public transit network by providing things like a brand new subway line and light rail transit projects as well. So whilst you get the bonus and the benefits from all of that economic development and investment, we do recognize that that volume of construction does have the potential to have negative consequences on people as they move around the city. And more specifically, whilst it can result in disruptions to sidewalks, road closures, things like that, we recognize that it has an even greater negative impact on people with disabilities and mobility and accessibility challenges. So the purpose of this project is really to explore different opportunities to improve the experiences of different accessibility groups. So we wanted to look at technology opportunities relating to people with sight loss, people with mobility devices, people with reduced stamina, individuals with hearing loss, and individuals with cognitive disabilities. And the reason we wanted to kind of split this out into different disability groups was to recognize that with each of these different disabilities, leads to a different set of needs when it comes to accessibility and when it comes to transportation and mobility. So, for example, if we're talking about people with sight loss, we're talking about solutions that can improve non-visual cues. People using mobility devices, solutions that are looking to tackle and understand smooth and stable surfaces, and so on and so forth. So we just wanted to really highlight at the outset of the project the different user groups that we would be looking at throughout the project. A few different objectives for this project. The first one was to hone in on technology opportunities to improve safe and accessible travel across the city with a focus on construction zones. We wanted to also look at the business practices and the way in which construction is sort of organized and laid out around the city as well. And then we wanted to get some real insights and detailed information on the specific unique needs and barriers experienced by people with disabilities when moving around the city, again, with a focus on construction areas. The approach to the pilot, as I mentioned, we split this into 2 different phases. We spent a lot of time and efforts researching best practice across a number of different areas. Devashri will talk through these in a little bit more detail shortly, but at a high level, we looked at the city's existing technology systems to understand what capabilities they already had. We conducted industry interviews with accessibility groups to understand the accessibility challenges firsthand. We spoke to a few different jurisdictions, both in the US and Canada, to try and understand the experiences from the agency side of deploying initiatives in this space. And then we also did a literature review, which was exploring some of the academic materials to learn best practice in deploying technologies in this area. From there, we then moved through to a pilot planning phase, so determining which technology solutions we wanted to pilot by doing a market scan and then setting up some of the criteria for designing a pilot. Pilot was then delivered, and then we moved through to this pilot evaluation phase. So we ended up testing 2 different pilot solutions, which we'll talk about a little bit later on. That testing was split into two parts. The first one was the technology testing around the functional performance of the solutions that were deployed, before then moving forward to doing some user experience testing, so getting people with disabilities to come out to the different sites and test the technologies firsthand. We've currently just concluded our technology testing phase of the project and are looking forward to moving on to the user experience testing part shortly in the next few months. So with that, I'll hand back over to Devashri to talk through the background research part of the project.
Okay, awesome. Thank you, James. So we can just get started. So we can go to the next slide and start talking about the existing systems. So we reviewed the city's existing systems, and this was to help us understand what are the technologies currently being used within the system, as well as to understand the existing capabilities, identify any ongoing pilot projects, and understand existing technology vendors. So what we found was that, so the technologies that we found, we categorized them into 4 domains. So those are the ones you can see on the left. I understand the photo is a little blurry, so I'll read them out. So it's city, highways, traffic operations center, and testing zones. So just some examples, for example, for highways, that could include Bluetooth sensors, variable messaging signs, and then for testing zones, that was any sort of area where the city is piloting any technologies, including this project. And what we did in the existing systems was we provided a further breakdown. So that's the image that you see on the right, where we're looking at the key technologies within the city domain. So that can include things like CCTV as well as traffic data collection. So we can move to the next slide, please. Great. So then we conducted a literature review, and we did this to understand the key challenges, considerations, and industry best practices for people with disabilities who are accessing the transportation network. So there were 2 key focus areas for the literature review. The first one was, it was guidance on developing successful pilots for accessibility. So this was considerations for the process of developing that pilot, including things like user engagement. And then the second focus area was considerations for introducing technology solutions to support DI objectives. So that was more related to like the actual application of technology. So the information that we found will eventually help support us for the pilot program evaluation, and the considerations spanned mobility, accessibility, and socioeconomic considerations. And the reason for socioeconomic is related to the statistic that you see here at the top. So this is a 2022 Canadian survey on disability for the city of Toronto. And what it found was that 41% of people with disabilities are employed, compared to 59% for those without a disability. And within that subset of people with disabilities who are employed, within that 41%, 60% of those Torontonians earn less than 40,000 Canadian dollars per year. So that sort of speaks to the fact that there's an overlap, like there does exist an overlapping group of people with disabilities who are also lower income. Next slide, please. So the way that we structured the literature review was that we wanted to introduce the concepts related to mobility and accessibility to the reader, in order to help them understand what it is that we're working with. So what we found was that mobility and accessibility are the resultants of multiple variables. This includes political and economic conditions, individual physiology and psychology, proximity, weather, as well as the time and day of the week. So in order to help you better understand all of the concepts and how they kind of feed into each other, we also found this figure that's here on the right, which are the four factors impacting mobility. And just to help it really stick, I'll provide a slightly, or not slightly, a very unrelated example, but hopefully it'll help. So we'll start with the top right, which is provider view availability. And in our example, let's just say we're working with a transit service provider. And from the transit service provider's perspective, they're providing transit all the time, 24/7. Now we go to the top left, which is immediate usability, and that's the individual's needs for independent navigation. So that kind of brings us back to those multiple variables and those needs. That could be the political, economic, all the other ones that I listed out. So all of that impacts the immediate usability, how accessible the service is for that individual. So given that, the user view, from the view of the user, let's say in this example, the user requires accessible transit services. Maybe they need paratransit. And in this example, maybe that transit is only available a couple of days or times of the week. Now, according to the user, transit isn't available 24/7. Transit is only available when that accessible transit service is available. So the user view availability is a subset of the provider view availability. And then cumulative usability is just, an overall understanding of how accessible and easy that trip is for the user. So hopefully that helps. But yeah, so what the key takeaway from all of this was that when designing a solution, it's really important to think of both perspectives. You have to think of the provider view perspective, where it's what are the locations and times for the services, and then you also have to think about the user view perspective of what are the locations and times based on the mode restrictions or the accessibility restrictions for that user. So how we did that for this pilot was that we conducted technology testing, which is related to provider view availability, and then we're also going to be conducting user testing, which will speak to the user view availability part. Next slide, please. So then we wanted to explore user experience and barriers. We found that there were 3 approaches that you can use to help understand the accessibility barriers or challenges a person might face. So these are personas, journey mapping, and usability evaluation. So the first one for personas, what that is that refers to it's when you can take a group of people, your target demographic, and you can interview them, and their answers, you can aggregate all of those answers and help build these anonymous kinds of personas. And these personas are considered to be reflective of the average user within that target demographic. And you can help use these personas to communicate challenges across different stakeholders or practitioners. Next is journey mapping. So journey mapping refers to sitting down with the user and either surveying them or chatting with them and trying to understand what their challenges are at every point of their journey. So there are 4 parts of a journey where we plan our journey, then we depart, we're en route, and then finally we reach our destination. And all of 4 of those parts can have different accessibility pain points. And lastly, usability evaluation. So this is, when you ask a user about factors such as how easy it was it for them to navigate, whether they had, sufficient digital connectivity, whether they found that they had enough space, how accessible it was for them, etc. And all of that can help you identify like a potential pilot location. It can help you identify whether technology might be needed. So once you have, all of that information and all of that data, it also helps to have a way to organize it. So this is what we have here on the left, which is the STEPS framework for transportation equity. And that framework has 5 different kinds of barriers. Basically, it's a way of organizing all of the barriers that you might find. So that's spatial, temporal, economic, physiological, and social. So using these sorts of frameworks and approaches can really ensure that your design remains social-centered, that it helps keep the user at the forefront. And later in the pilot planning process, we use the STEPS framework to help us identify the barriers that our technology would help with. Next slide, please. So following the literature review, we conducted a couple of industry interviews. So that was really to understand accessibility challenges as well as any considerations for technology solutions. So for accessibility challenges, that includes what we found was economic barrier so we talked to CAMH and CNIB. So CAMH is the Center for Addiction and Mental Health, and we also talked to CNIB, which is the Canadian National Institute for the Blind. And basically what we found was, the first thing is that economic barriers exist, and that can make it hard for people to access services, including accessing transit to access services. Second, we found that there's a growing digital divide. So that means that there are people who aren't really comfortable with using or accessing technology, including online banking. And then the next couple of pieces were related to construction. So we found that construction can often cause route disruptions and difficulty in locating accessible pedestrian signals. So that's because whenever there is a construction zone, and if it wasn't really expected, a person might lose, familiar landmarks or things like that, which they use to independently navigate. And the construction zone signage might not be sufficient. And lastly, snow accumulation can also help with the visibility of landmarks and that sort of stuff. So the overall feedback that we got from this part was that it's really important to have early and continued engagement with the user groups that you're looking at, that implementing a technology-based solution can sometimes introduce new challenges on its own. And lastly, the importance of real-world testing for navigation technologies. Next slide, please. So really quickly, lastly, we talked to a couple of jurisdictions, and the one that we want to highlight for you today was our conversation with MassDOT. What they did was they used technology as a training tool for empathetic leadership. So this was their Empathy at the Intersection initiative, and what it was a way to show transportation professionals how it is to like be at the intersection, for example, as an older adult. So at the top, you can see the image of the person in an age suit from MIT Age Labs. And that, simulates how it might be to be an older adult crossing the intersection, for example, with mobility challenges or visibility issues. And the bottom left image is a truck, and what they did was they asked professionals to get into the driver's seat of the truck to help them understand how limited a driver's visibility is at the intersection. So just some of the key takeaways from this initiative was that learnings that you get from these initiatives or pilots must be tracked and accrued, especially if you're doing public and private partnerships. It's really easy for information to get lost. You should have consistent staffing, so have staff that are the same sort of staff for beginning, middle, and end of a project. And lastly, leverage research partnership and collaboration opportunities wherever possible. So with that, I will hand it over to James to talk through the phase 2 pilot solutions.
Great, thanks, Devashree. So based on the background research phase of the project, we got a really good understanding of the specific accessibility concerns and challenges experienced by people with those in those different disability groups. And we also got some ideas around how technology can be used to support in that area as well. So from there, we wanted to take that learning and then look to identify a couple of different pilot projects to test technology solutions and just understand how they can improve the experience of accessibility of people moving around construction zones. So we started off by conducting a market scan, which was really to understand the available solutions out there in the market that can help in this area. In order to conduct that market scan, we ran through a few different steps. So the first one was just around establishing the search criteria, so being very specific with what we were looking for out in the market in terms of technology solutions. So that involves being specific around our target user groups, the search objectives, so specifically what types of technology we were looking for and what challenges we were looking to address. And then some other criteria around a preferred level of technology maturity, cost implications, and then also some criteria around how easy or difficult it would be to integrate into the city. From there, we then identified a number of different technology solution vendors. So we got that information from the existing systems work that we'd done as part of the background research task to understand the existing suppliers to the city. We had some insights from the discussions with CAMH and CNIB around technology solutions that users within those groups were already using to help with their navigation experiences. And then we also identified some solution vendors just from some market outreach and research efforts. So from there, we did a few interviews with different vendors. We did some research into the different solutions, pulled the information all together to ultimately help us to determine which ones we wanted to move forward to pilot within the city of Toronto. So the findings from the market scan were that we found 27 different technology solutions, which were provided by 21 different vendors. And then what we found across those 27 different solutions, they typically fit into 4 of these different functions provided these types of function or use case. So the first one was around technologies that were able to detect and analyze user behavior. So for example, camera-based systems that were able to detect different classifications of pedestrians and cyclists, and also analyze how they would move around intersections, for example. The second one was there was a lot of solutions around providing information, so either advisory messaging or warnings to road users. That would either be a sort of immediate warning message, so lighting up a crosswalk so it's a little bit more visible to road users and pedestrians when it's safe to cross. The other side of that category was there was a lot of solutions which were providing navigation assistance to pedestrians, either through like audio descriptions of navigation steps. The third one was taking that information and providing additional crossing time for users who required additional crossing time. So maybe people using mobility devices or for the visually impaired, identify those types of users and give them more time to cross the road. And then we saw a number of different solutions that were providing specific work zone information in an accessible way. So alerting systems to hazards around work zones, warning signs, beacons specifically to alert people with accessibility needs around the hazards around work zones. And then what we found also was that within those 4 different functional areas, those solutions were delivered via a number of different technology types, which typically fit into these different buckets. So large number of video analytics solutions using camera feeds to detect and analyze road user movements. A number of different smart sensor solutions, so things like LiDAR, and other detection devices that were able to detect hazards and activate different warning systems, as I mentioned. We had a number of different sort of smart signage solutions, which would provide higher resolution imagery messaging to road users to give them information about hazards around work zones more sort of accurately. And then the fourth Fourth technology area was a large number of different mobile apps that were providing accessible, primarily navigation information to users who needed that. So off the back of the market scan, we wanted to then move forward and look at how we choose some solutions and set up a pilot project. So we set up our pilot objective, and that was to test emerging technology solutions to understand the potential safety and mobility impact for at least one of the accessibility groups that we defined at the start of this presentation, and then set up a number of different key research questions, which are pairing of the accessibility challenges that we'd learned about and also the technology opportunities that could be used to address those challenges. So from there, we then set up a sort of a testing plan and procedure. So as we mentioned earlier, we split up the testing into these two different components. The first was the technology testing, just to understand that the technology was working as per the manufacturer's instructions and intentions. Once that was proved to be successful and the technology was out in the field and working properly, then looking forward to moving to understanding the effectiveness specifically around accessibility for those solutions. So we know that from a technical perspective, the technology is delivering what it should do. Now we're trying to understand, okay, how effective is it in improving the experience of people with accessibility needs? So we had two different pilot projects that we've deployed. I'll talk through each of those briefly now. The first one was a mobile app provided by Polera. So Polera, in collaboration with their distributor Taysel, they provide the accessible pedestrian signals for the city of Toronto. The PED app is a mobile app that is an add-on to the accessible pedestrian signals, and it provides detailed audio information at intersections. So you're able to activate the intersection signal via your mobile phone, which is helpful for people with visual and people using mobility devices. And the app will then also provide audio information on the status of the crossing. So it will give advisory information on when the walk sign is on with an accompanying vibration of the mobile phone. And then it will also provide the countdown information and then also a don't walk message when it's not safe to cross. So we initially rolled this solution out at just one intersection, just to manage the deployment of it and understand how it worked in the field at one site to start with. So we configured it at King and Brant, which is a slightly quieter intersection, just gives us a little bit more space to be able to test things out and understand how it works in the field without it being a really, really busy intersection. The configuration was undertaken by the city with Taysel over the course of the summer this year. So the findings of the technology testing were that we were focusing on two areas specifically, and that was the key functionality of whether each of the features of the system worked, and then also the message accuracy. So understanding the latency of messages between the physical signal and what was being displayed on the app, making sure there wasn't too much of a difference between the countdown information on the app versus the physical signal, for example. And then we captured a number of different observations which would be useful to capture when we move through to the user experience testing. So they were focused more on the sort of the usefulness and the effectiveness of the solution rather than the technology aspect. So the testing concluded that this was operating as intended, and the tests were successful, with the outcome to move through to the user experience testing next. The second solution that we piloted was provided by Remudan in collaboration with their contractor PCL at a construction site that they are providing the traffic control for, also in downtown Toronto. This solution is a truck warning system, so it's there to provide advisory information to pedestrians and cyclists primarily when there is a truck exiting the site. So currently the system is activated via a manual push button. And what that'll do is once the push button is activated when there's a vehicle waiting to exit the site, it will then activate these different warning signs and signals. So there is an audible alert which provides a message indicating to pedestrians to wait while there's a truck about to exit the site. And then there's also a visual alert, which is a flashing beacon, which also just emphasizes that it's not safe to cross the exit site at that point. The solution also has a smart camera element to it with a view to be able to automate the activation of this system with removing the need for a person to physically press the button. The first phase of this pilot was to install the solution using the manual push button to start with a view to then deploying the automated activation using the smart cameras at a later date. So similar to the Polera PED app, Remuden undertook some technology testing of this solution, and a number of KPIs were developed primarily around each of the different system components. So just testing and optimizing the operation of each of those components, making sure that they work, refining the timings of them, and so forth. That was done again over the summer this year. The findings were that by the end of the sort of iterative testing process, all of these system components were up and running. The counting and analytics and the conflict analysis, the last two KPIs are more focused towards the automated detection and activation element of the system, which is will be coming in the next few months. Just in the interest of time, I'll skip on. We did make a number of different observations around the sort of condition of the sidewalk and accessibility concerns for the Remuden system, but I'll just skip on to the summary and reflections just so we've got enough time for questions at the end. So in terms of next steps for this project, as I mentioned, we're looking forward to moving forward to the user experience testing phase of the project, which involves working with different accessibility groups like the CNIB to get people who are experiencing different disabilities to come out to these different pilot sites and test how they find using the technology systems. Following that, if those tests prove to be successful and the solutions are useful and effective, we'd then look for opportunities to roll them out further across the city. So, for example, for the PED app, maybe configure a few more intersections around the city and promote the system a little bit more widely. For the Remuden site, it could be looking to seeing how we could provide that at a number of different construction sites rather than just at the single pilot site. And then the other part in terms of the next steps is the city is continuing to look for and open to hearing about technology solutions that can support in improving accessibility, and are planning to issue a request for information in coming months to sort of get more information from different technology vendors around how they can provide services to the city that can improve accessibility. So I'll just finish with this final slide, which is around key takeaways. So what do we learn from this project? So the first takeaway was to listen and not assume. So really putting a heavy focus on lived experience when we're listening to accessibility challenges and trying to understand the barriers to accessibility and mobility. Check your thinking, not boxes. So this is around using compliance with standards and legislation as a starting point, but really thinking more empathetically and holistically about how these solutions can actually unlock some of those barriers to accessibility. We wanted to recognize that technology can help if it's done correctly, but technology that is difficult to use or has a high sort of barrier to entry can actually perpetuate those existing barriers and make things worse. So we have to keep telling ourselves to keep things simple. The next one is around co-creation over distribution. So just putting emphasis on the value of collaborating with stakeholders from the start and throughout the process to collaboratively deliver solutions. And then the final point I just wanted to touch on was to start small and build up. So when we're looking at technology deployments and pilot projects specifically, it's always sensible to start with a limited scale of deployment, make sure that you can iron out any of the kinks in the installation of the configuration, get a good understanding of how the technology works before you then roll it out and deploy it at a wider scale after that. So that concludes the presentation element of the session today. So thank you for attending and listening. And now I think we've got a bit of time for questions. I'll just put the project team's contact details on the screen as well, if you want to reach out to anyone at WSP or at the city for further information.
Thank you so much, James and Devashri. That was an amazing presentation. So I have a couple questions in the chat. I will start for this one that is 3, so I will go one by one. What was the outcome of pay scale of demography, why it was needed?
Yeah, sure. So I can take this question. So really the outcome of that statistic was it wasn't so much focused on the numbers as it was to understand whether it was necessary to research that intersection of people who have disabilities and who also are or who experience lower income. So yeah, that was really the one of the outcomes. And then I think the second outcome was that it helped us ensure that our technology solution was accessible to the user. For example, the Pet app is free. And yeah, so hopefully that answers that question.
Okay, thank you. On the same note, from where did the demography data was collected? Like which year data?
Year? Yeah, so the year was 2022. It's 2022 data.
Okay, and have you accounted for increase in number?
Like I said, the purpose wasn't really for the numbers, but whether to understand that the population exists. So I think the considerations that we provided in the literature review should help should that demographic increase in number.
Great, thank you. Next one is, as this is a development project, what was the biggest challenge you have come across in your project? Like any slippage or scope not accounted in planning or something like that?
Yeah, I can take that one. So there's probably a couple of things I could talk to on this one. One of them is, I think inherently when you're testing anything new, and doing a pilot project, you're going into the unknown. So no matter how much you plan or try and preempt any of the challenges in deployment or planning or coordinating, things always come up that you can't predict. So you have to be a little bit agile to be able to tackle those issues as they come up and be collaborative and work those things through together. And then the second, another sort of challenge that we sort of came across was we put a lot of emphasis on that background research part of the project and understanding best practice. And we got so many insights and so many different takeaways from that to take forward into the pilot deployment. The challenge then becomes, how do you put all of those things into action, and how do you sort of follow through on those best practices? It's great to sort of learn about them and understand them, but then taking them forward to actually putting them into practice when you're designing a pilot program does have challenges, and it can be tricky to align all of those together as well.
Perfect, thank you. Next one is, what processes are used to ensure that contractors properly install this technology in the way that designer intended?
Yeah, I can tackle that one too. So in relation to this project example as well, Remudan, they worked very closely with their contractor at that specific site. They were involved throughout the design, the development, the ideation of the solution. They went through a number of different versions of how the technology would function, and that was based on a lot of feedback from what the contractor wanted to do and how it would affect their operation of the site. So it was on one hand, a sort of a co-developed solution between both the technology provider and the contractor on that side. Since that was done under a sort of testing environment, and it was the first time that had been done, they worked together very closely, and there wasn't necessarily mandating or setting out a specific process for how to do it going forward. That's kind of part of the next phases of then how you scale it up and roll it out more widely across different sites across the city, or in different municipalities or different jurisdictions. The focus of this was really to make sure that the technology was operating and working as intended.
Okay, great, thank you. So next one is, how much should a city budget, I guess, put on smart mobility technology solutions versus mandating construction industry to implement solutions?
Yeah, that's a good question. So I think the way I'd view it is that this project is focused on technology opportunities to improve accessibility around construction sites. technology is one way in which you can improve accessibility among many others. The other ones could be procedural, like mandating the way in which a construction zone disruption is communicated to road workers, whether that be through a technology means or just a traditional signage means or any other sort of notification methods. And then there's many, many other ways to improve accessibility, whether that be through designing and deploying accessible physical infrastructure in terms of tactile road surfaces and so on. And then each of those can be sort of implemented and imposed, I guess, through a few different means, whether it's guidance, whether it's mandating, whether it's following legislation set at different levels of government. We'd like to kind of view the technology as one component of a system that is all working in the same direction to improve accessibility across the board.
Amazing. Okay, so I don't have any more questions for now. I have just two comments that I would like to share. One from Rhonda that says clever and understandable visual. Thank you. And one from Nick Hill that says this functionality of alerting pedestrians of heavy vehicle is very useful. Great work. So thank you so much, everyone, for your questions and comments. I think we reached out the time as well, so you can wrap up.
Perfect. Thank you. Thanks for attending, everyone.
Thank you, everyone.
Thank you so much. Have a great day.